Hello learners, welcome students. I am Dr. Prasad Narayan Patil, Assistant Professor in Physics from Ganpat Parsekar College of Education, Harmal, Goa. Today I am discussing in this module that is Everyday Physics with Demonstration. My module name is Dynamics of Heat. Outline of my talk will be units of temperature, heat, heat transfer in nature, conduction, convection and radiation, and finally Newton's law of cooling. In this model, student will going to understand to convert temperature from one unit to another. What is a heat? Three processes to transfer heat, that is conduction, convection and radiation, and finally Newton's law of cooling. So basically temperature we define is nothing but it is a degree of hotness or coldness. So if you take an example of a boiling water and a soup, we will going to get the information of the hotness and coldness with the help of thermometer. So thermometer will decide whether the boiling water is hot or a cold. So here I just specify the two examples of the boiling water and the soup, and that will going to decide the degree of hotness and the coldness. What is the temperature? Temperature is nothing but the measure of how hot or cold something is. It is a physical property of matter. As length can be measured using various units, example meter, kilometer, centimeter, etc. Likewise, temperature also has various units. The SI unit of temperature is Kelvin scale. Standard units are Celsius, Kelvin and Fahrenheit. So how we define thermometer? Thermometer is used to measure the temperature, and if you see the figure, the thermometer consisting of 2 points denoted as lower fixed point and an upper fixed point. So types of thermometer. There are three types of thermometer. One is a Celsius scale thermometer, second one is a Fahrenheit scale thermometer, third one is a Kelvin scale thermometer. So these are the three different types of thermometer. So if you see the Celsius scale, the lower fixed point will be 0 degree Celsius, and upper fixed point for a Celsius scale thermometer is 100 degree Celsius, and the difference between the lower fixed point and the upper fixed point, that is the middle of this Celsius scale, is 100. In a Fahrenheit scale, the lower fixed point is 32 degree Fahrenheit and upper fixed point is 212 degree Fahrenheit, and the difference between lower fixed point and upper fixed point is 180 degree Fahrenheit. In a Kelvin scale, the lower fixed point is 273 Kelvin and upper fixed point is 373 Kelvin, and difference between the lower fixed point and upper fixed point is 100. So basically, if you see the this scale of the thermometer, the degree Celsius thermometer is larger than the Fahrenheit scale, than the Kelvin scale. So we will going to understand now how to convert one scale to the another. That is, how to convert degree Celsius into degree Fahrenheit, or degree Celsius into Kelvin, or degree Fahrenheit into Kelvin, or degree Fahrenheit into degree Celsius, or Kelvin into degree Celsius, or Kelvin into degree Fahrenheit. So take consider one container. In this container we are using a ice bath is used, and the three different thermometer are inserted. So as a temperature will going to rise of the three different thermometer, and then we can get three different values, that is A, B and C. Okay, so A is nothing but the lower fixed point and B is nothing but the upper fixed point and C is nothing but the difference between the 2 points, that is AB. So the standard formula used for this three different thermometer will be CB upon AB equals temperature of one scale minus the lower fixed point divided by the total division between two fixed points. So basically we can write for a Celsius scale, Fahrenheit scale and Kelvin scale this one temperature of one scale, that is a degree Celsius, minus the lower fixed point, that is a 0 for a Celsius scale, divided by the total division between two fixed points for a Celsius scale is 100. In a Fahrenheit scale, the temperature of one scale is degree Fahrenheit minus the lower fixed point is 32 divided by the total division between two fixed points is 180. In a Kelvin scale, the temperature of one scale will be denoted as a variable K minus the lower fixed point is denoted as a 273 divided by the total division between two fixed point in a Kelvin scale is 100. So we'll see now one by one how to convert Celsius scale to Fahrenheit scale. So basically we have written in a previous this thing Celsius scale, that is a CB by AB equals 0 degrees Celsius minus 0 divided by 100, and then Fahrenheit scale what we are getting CB by AB equals 0 degree Fahrenheit minus 32 divided by 180. So this CB by AB in a Celsius scale and Fahrenheit scale are equal, and therefore we can equate these two equation, that is a degree Fahrenheit minus 32 divided by 180 equals degree Celsius minus 0 divided by 100. And when we rearrange this equation, what we are going to get is the degree Celsius equals 5 bracket degree Fahrenheit minus 32 bracket closing bracket divided by 9. So if one want to convert the Fahrenheit into Celsius scale, then we can get a 9 by 5 into degree Celsius plus 32 equals degree Fahrenheit. Now in a second case, the Celsius scale to Kelvin scale. How to convert a Celsius scale to Kelvin scale? So we can use this formula, that is the Celsius scale CB by AB equals 0 degree Celsius minus 0 divided by 100, and the Kelvin scale CB by AB equals Kelvin minus 273 divided by 100. So since both are left hand side both of the Celsius scale and Kelvin scale are equal, therefore we can equate these two right hand side, and we will going to get that Celsius scale should be converted into Kelvin scale. So here you can see that K is a Kelvin minus 273 divided by 100 equals degree Celsius minus 0 divided by 100. So when we rearrange this left hand side and the right hand side, then what we are going to get is the K minus 273 equals degree Celsius. So this is the form that we can convert into Celsius scale into Kelvin scale, or some want to convert a Kelvin scale into the Celsius scale also. Now in the third case, how to convert Fahrenheit scale to Kelvin scale? Again, Fahrenheit scale is given by this formula CB by AB equals degree Fahrenheit minus 32 divided by 180. In a Kelvin scale, CB by AB equals K minus 273 divided by 100. When the left hand side of both the Fahrenheit scale and the Kelvin scale are equal, then we can equate the right hand side of the both the Fahrenheit scale and the Kelvin scale, that is the degree Fahrenheit minus 32 divided by 180 equals K minus 273 divided by 100. And when we rearrange this form of the two equating equation, we can achieve a Kelvin scale, that is 5 degree Fahrenheit minus 32 divided by 9 plus 273. Or if you want to know degree Fahrenheit also, then we can get a 9 by 5 into K minus 273 plus 32. Now we are going to know what is the heat. Heat is nothing but the sense of touch. So you are going to see in a right hand side of the one of the beaker is having a water, and then we can have the sense of touch of the heat by touching our hand onto the beaker. So it is a sense of touch. How what we say that heat is nothing but the sense of touch. So it can't be seen by naked eye also. So heat is a form of energy. And energy, we know that ability of doing work. So take an example of a cooking in a utensil. When we supply heat energy from below to the utensil will supply the energy to the water in this utensil, and the work will be done. So energy is what we say that ability of doing work. Basically, transfer of heat in nature is carried out by in this form, that is heat transfer from hot body, that is higher temperature, to cold body, lower temperature. So if we consider two metals, one metal is having a 50 degrees Celsius and second one is having a 20 degrees Celsius, and both are both can exchange the heat from a 50 degree to the 20 degrees Celsius metal, and they will achieve a thermal equilibrium at 40 degrees Celsius. That means what? The heat transfer from the hot body, that is 50 degrees Celsius, will be carried out into the 20 degrees Celsius second metal, that is a cold body, and they will attain a thermal equilibrium at 40 degrees Celsius. So we can say that when two bodies or two different parts of the same body have a different temperatures and are brought into thermal contact, they can exchange heat energy and tend to equalize the temperature. Three processes to transfer heat. First one is the conduction of heat. So in the conduction of heat, the process of transfer of heat from one place to the next is carried out by collisions, and this is known to have a conduction process of a transferring heat. So take an example of a metal which is been heated, and then when you are touching your hand or a finger, then with the collision process, the conduction of heat will be carried out to the finger of the hand. Second way of transferring heat, that is the convention of a heat. So heat transfer due to movement of particle. So if you consider the two different example, that is a fluid, liquid or a gases. So one of the container is heated, and if you are just placing your hand above that, you will going to see that heat is transferring from the container to your hand. So this is one of the method of transferring the heat from the movement of particle from container to your hand. In a second example, if you are having a heated water in a beaker, and when you are just dipping a crystal into the beaker, the crystal will absorb the energy from the heated water in a beaker, and this way the transfer of heat will going to take place from the water molecules to the crystal molecules. Third thing, transfer of heat will be carried out, that is a radiation of a heat transfer due to electromagnetic waves. It is well known that most of the space between the sun and the earth is in a vacuum, and there is almost no trace of matter in that space, and we receive heat from the sun. So electromagnetic wave don't require any medium, and they can pass from the vacuum. So radiation of the sun energy or electromagnetic waves is carried out in the form of radiation of the heat. So this is one of the heat transfer is carried out in the nature. And in the artificial example of a radiation of heat, what we are getting is the nothing but the microwave oven process, where the electromagnetic waves are transferring the heat energy. This is the first example. Second one is ion process. Also the heat transfer due to electromagnetic waves is carried out in ion process. And third one is the sun radiation. So let us see what is the definition of the heat. It is nothing but the total kinetic energy of all the molecules, that is translational, vibrational, rotational of an object. So consider one example of a container in a beaker. When you are supplying heat energy below to the container, what will going to happen, that the boiling of water will going to take place. So there is a translation, kinetic energy will going to take place. And the same, when you are supplying more heat energy to this container, what will going to happen, that the molecules will going to have a vibration kinetic energy. And further, if you are supplying more heat energy to this container having a boiled water, then will this vibration energy is converted into rotation kinetic energy. So this is the definition of the heat. So basic characteristics of it is, heat is a microscopic concept. Heat is a scalar quantity. Its SI unit is joule, and dimension equations are nothing but the joule equals Newton per meter, and then we can get nothing but the dimension formula for this heat is nothing but the ml square T minus 2. And finally, Newton's law of cooling. Let us see the basic statement of the Newton law of cooling. The rate of loss of heat by a body is directly proportional to the temperature difference between the hot and the surroundings, provided the temperature difference is small. So if we all know that if a temperature of surrounding in the figure what is being shown, that cooling of a hot water with time. So as a time progresses, cooling of hot water initially at a lower time is very fast, very rapid, but as the time increases, then the cooling of hot water decreases. So what we know, that body can't reach at the surrounding temperature Ts, and the Th is nothing but the room temperature. So in order to reach the body at a particular room temperature, that is the surrounding temperature Ts, the time taken by the body to reach to surrounding temperature will be infinity, or in nothing but the what we say, then it will be infinity. References for this module will be P.J. Haviett, Conceptual Physics, 12th edition, Pearson. Second one, David Halliday, R. Rusnick and J. Walker, Fundamental of Physics, Extended 5th edition, John Wheely and Sons. Third one, M. N. Saha and B. N. Srivastava, Treatise on Heat, the Indian Press. And finally, the reference will be S. C. Garg, R. M. Bansal and C. K. Ghosh, Thermal Physics. Thank you.